So I'm trying out this city builder simulation game on Steam called Patron, and I'm kind of a cheapskate, so I started with the demo version. Well, I'm playing along for a bit when I hit this dreaded screen. What? I have to stop playing after 2 hours? Well, I was having fun up till now, so I probably should just fork over the 20 bucks, but I thought it'd be more fun to hack it instead. If you're new here, my name is Devin, and this channel is for coders interested in gaming, hacking, and AI. In this video, I'll show you how to remove this 2-hour time limit. But to ease my guilty conscience, let me give a disclaimer. This is only for educational purposes. And to be honest, the demo is locked down in several other ways, so you really need to buy the full version if you want to keep playing. Okay, let's get started. So if I click this OK button, it's going to quit me out of the game, so I can't keep playing. Now I could just start a new game and start all over, but then again at the 2-hour limit, I'm going to get kicked again. So if I reload this game, the easiest way, in my opinion, to do this is to look at the text on the screen. So in the original language, I don't know if this was coded in C++ or C# or Python or what, I don't know. But in the original language, they probably have some kind of if statement that says, if the amount of time that's been played is more than 2 hours, show this message and quit. Well, that if statement is going to get turned into zeros and ones. You're not going to be able to easily search for that. If you found out what language it was coded in and you ran it through a decompiler, you could find that if statement. But the best decompilers are still not going to produce perfect code. So even if you delete that if statement, you can't recompile it without doing a whole bunch of fixes to the code. So instead, we want to edit the actual zeros and ones themselves. But you're not going to be able to search for an if statement inside of zeros and ones. But what you can search for is this text. So what I'm going to do is just write down this thank you for downloading into Notepad. And I probably don't need to copy down the whole thing. And then I'm just going to put that in my clipboard. So copy. Then I'm going to search the folder that the code is in and see if I can find this variable somewhere. Okay, so first I need to find out where this game is located. So if I open up my task manager and go to details, I can find the game that I'm playing, Patron. Then I can right click on it and do open file location. The exe is going to have the actual zeros and ones to the code, but these other folders might have 3D models, etc. So I'm going to take this folder name and I'm going to search everything in this folder for that text. So I'm going to take this folder name and I'm going to open up a tool called Visual Studio Code. You don't have to use this tool, you could use other tools, but I'm just going to go into the search and I'm going to tell it to search inside of this folder. And then I'm going to take the text I typed and search for that text. The reason for this is that text might be in the actual exe, but commonly programs will be translated into multiple languages. And so those types of text will usually be in a configuration file of some sort instead. So if I compare the original screenshot, thank you for downloading, as you notice, features are locked out. That message, exactly the same right here. This looks like a variable name right here. So I'm gonna copy this and then I will search for that in the actual code. To actually look at the code, I'm going to open up a program called OllyDbg. And there is a freeware copy of this. You can just download it if you Google for it. And there is a paid version as well, but you don't need to use the paid version. Okay, and then I'm going to open up this patron.exe from this folder in IDA. Just do new, and then paste in my folder, and then click that. Okay, so first it's going to ask me how to disassemble. So assembly is a language that most closely represents the zeros and ones that the operating system uses to execute a program. And so each operating system is going to have a slightly different version of assembly language. So like Android or iPhone or Mac or PC. Anyways, I'm just going to leave it with the default here. Okay, so now it's saying that it wants to open up a PDB file. That is for debug symbols. So if I had a PDB file and I wanted to decompile it into like the original C++ code, then the debug symbols would be very useful because that will tell me the real variable names. Because the coder maybe would, like in an if statement, use a variable name like game time or game length or something. But once it's been compiled, the variable name won't exist anymore. It's just going to be an address, so like a random number. So the debug file would be useful for that. However, it's very rare to have a debug file in like a commercial product because you'd have to be the original developer to have access to that file unless you distributed that to your users for some reason, which most people don't. Anyway, so it's saying it can't find it, and it's asking if it wants me to search Microsoft's database of symbols or like debug symbols, but I'm going to say no because I know it won't be there. That would only be for like open source projects. Okay, so here's the code, but notice this is not C++, this is assembly language. So it kind of is human readable, but not exactly. What I have highlighted says CMP, ECX, comma 1, and JGE short, lock underscore, and some random numbers. That is basically an if statement, like you would see in C++. But so you'll notice that things are very complicated in assembly language. So CMP stands for compare, and it's going to compare two different values. ECX is what's called a register, and registers are very similar to variables, except that they are inside of the CPU itself, whereas most of your memory is inside of RAM. So like in your computer, your RAM might have like 16 gigs or something, like a lot of RAM. So registers are basically like memory, but they're super fast because they're inside of the CPU itself. Whereas RAM memory is on a different part of the motherboard and it takes a while for the electricity to go back and forth. So you only have a couple of registers and they can only store a small amount of information. So data has to get moved from memory into a register, which is kind of what it's doing here. So this MOV, it's taking some random address, which we have no idea what's in there, and it's going to copy it into the register, and then it's going to compare that register to the value 1. So compare essentially is just subtracting these two values. So it's whatever's in that ECX register, which came from that memory location, it's going to subtract 1 from it. And whenever it does compare, it sets a few flags like negative, positive, 0, overflow, things like that. And then this J stands for jump, and the GE stands for greater than or equal. So because it just did a subtraction, then depending on if it turned out to be a negative or a positive, it would know if when it compared the values, if it was greater than or less than. So it's saying like, if it's greater than or equal, then jump to this specific location, LOC underscore. And you notice when I highlight it, it also highlights down here. So the arrow on the right, if it's greater than or equal, it's going to jump here. But if it doesn't jump, it's just going to keep continuing down. So it's just going to be one line down. If we got rid of this like flow chart, then you would see that this LOC is actually it's the line of code immediately below this MOV window. So if it's basically by jumping, it's skipping over this MOV command, but if it doesn't jump, it'll run the MOV and then continue with the same line of code. So really the if statement is just wrapping around this one statement. So it'll skip that statement if it's greater than or equal. We don't need to necessarily know what this if statement means because the code is huge, multiple megabytes worth of code. We don't need to care about every individual if statement. This is just the first thing that kind of popped up. We want to be smart with how we search because we're not just going to read every line of code. Instead, we want to search for the exact error message. So I'm going to come up here to search, and I'm going to say text. So I'm going to search for this, and it'll give me the first occurrence that it finds. Okay, so it's saying right here, so this label is basically a variable and it exists at this exact address, this location in the code. But the value of this label is text, and this is the word that's inside of that label. So the actual text of thank you for downloading, that is not inside the executable anywhere. Only this key. And somewhere in the code, it's going to say to open up that file, read the text inside of it. But we don't care about how it reads, the correct language translation out of the file. We just care about this label, this address. Now that we found this address, I'm going to right click on it and I'm going to say list cross references to. That will show me anywhere that this variable is used. So there's 2 of them. So I'm going to select both of them and I'm going to add a breakpoint to wherever it's used. So I'm going to right click here, say add breakpoint. And then I want to go back to the previous screen I was on, the search results. If you hit escape, it'll jump you back. So I'm going to do list cross references again and select the second one. And it's right here. So I'm going to also right click here and add a breakpoint. Right now I'm opened up this executable to analyze and I've added breakpoints, but I haven't actually attached to the program that's running. So I have to go debugger, attach to process, and then search for patron. So a process is inside of your operating system like Windows. The process is the actual program that's running in memory, and the same executable could be running multiple times. Like you can see Chrome, I must have like 1 million tabs open right now because there's a whole bunch of different Chromes. So, and some of these programs could be things running in the background that you don't even see on your screen anywhere. I have to tell it that I want to attach the debugger to that game. Now you see it popped back into the game, and I know for sure I'm not at a breakpoint because as I move around my cursor, I can see the game is functioning. If the game freezes, then that's a good indication that I'm at a breakpoint, but I can also always tab out and I can see if I'm at a breakpoint. Load my game. Okay, so instantly when it hit the breakpoint, it switched me to IDA. I did not have to like tab back and forth. So I knew that it hit the breakpoint. I can tell it to just continue and then it should show me the error message. Yep. And it's unfrozen again. The breakpoint that it seemed to hit was this top one, I believe, not this bottom one. I should have been paying more attention. But the reason that's useful is since I have 2 breakpoints, that means there's 2 places in the code where it might show this message. And I don't necessarily care about this bottom one if it's not actually being used. So I'll probably remove that breakpoint. But let me just reload the game one more time and just double check which breakpoint I was on. I could also remove like this top breakpoint. I'll just disable it and leave the bottom one and then continue. And then I'll reload the game and just see if I hit any breakpoint at all. But I don't suspect that I will, so that kind of tells me, yeah, so I got exactly to this error message. So I know for sure it's this top one, it's a breakpoint that I disabled. So I don't even care about this bottom one. Okay, so now there are 1 million lines of code here. We're gonna have to try to figure out what this is doing. If I were to try to read through all this assembly, it would take a long time to read it and to explain it. However, there is a tool, switch to source. So you can see here, this looks kind of like C++. So the variable we are looking at is this demo timer end. So it's saying call this function on some variable, and then if the value equals 1, then call this other function. So you can tell, like, even though this is technically C++, it's really ugly because you don't have any variable names. You just have like random addresses. So that's where the PDB file, that debugger symbol, would have came in really handy. Even though I could read this, like try to read this code, I'm gonna fail miserably. Instead of trying to analyze each individual line, we have to kind of do more of a broad approach where we kind of modify the code slightly, add breakpoints to other places, and just kind of do trial and error. And also maybe try to skim over the code as a whole. So I don't need to necessarily worry about what this function is doing or what this variable is, but maybe just try to figure out the overall, what is this like whole section of code trying to do. It sounds like it's trying to basically look up the English translation for the word it's going to show on the screen. And then if it can't find it, it's going to show this error. And that's probably just going to get logged to a file or something that the developer can read, and then it's going to keep going. So it's talking about like labels and text. So this is probably just rendering it on the screen. And if I scroll up, you know, it's talking about a close button, a status bar. But what's interesting here is this case statement. So it says case 8. So in C++, a switch statement is kind of like a giant if that has multiple options. So this case 8 seems like it might be all related to quitting out of the game if I've been over the 2-hour time limit. But so like this case 7 up here, it might be something completely different, not even related to quitting out of the game, or not even related to running out of 2 hours. But it still says like background, close button, text box. So maybe this is just a different type of message that might show. So anyways, the reason it overall matters is because if we are drilled in too deep and we make like a change to the code, we might be changing the completely wrong code. So for example, if I just deleted this line of code, it's not necessarily going to allow me to keep playing the game for more than 2 hours, because this line of code is just reading that English text. And then somewhere else, like maybe this call function is going to like render it on the screen or something. But that doesn't mean this is the function that quits me out of the game. And what I need to do is prevent it from quitting me out of the game. So what I'm going to do is I'm going to add more breakpoints to find the if statement that says if I've been over 2 hours, I'm done. So I want to keep adding more breakpoints like higher up. So I'll like do add breakpoint here, add breakpoint here. And I want to find the highest up piece of code that still hits the breakpoint because I'm on 2 hours, followed by a breakpoint right above it that doesn't get hit. So that kind of tells me like if I found of where this logic starts. So because this is kind of in a workflow format, I can just scroll up until I get to the end of a big box and see like the arrows, because each of these arrows is basically going to be an if statement. And even though I was looking at the C++ code, that just helps me kind of read the code a little bit better, but in the end, I'm still going to have to deal with the assembly. So I'm going to add a breakpoint to the very top of where this function started, and then I'm also going to check for the if statement that it came from. So I'm just going to follow this red arrow. And so it came from this if statement, so I'm going to add a breakpoint here. It always comes from the same arrow. So breakpoint. Breakpoint. So it doesn't really matter how far I go. I'm just going to keep going for a little while. Oh, it looks like I got to the very top of the function. Okay, so I'll just do all of them. Now, in order to troubleshoot where we're kind of doing a trial and error scenario, we have to have two examples. We have to have an example where the game doesn't crash and an example where it does, because that way I can compare side by side and see if I've hit the right breakpoint. So what I'm going to do is in the game, I'm going to create a brand new one, because the 2 hour time limit is per map. This time I didn't hit any breakpoints. So let me load Demacia, which is the one that has the 2 hour limit enforced. Okay, so this tells me that if I load the Demacia map, which has the 2 hour limit, it hits this very first breakpoint here. But if I load the Jamestown map, which has only been playing for 1 minute, this breakpoint does not get hit. So that means all the code below here that I've added breakpoints for, they are all too deep in the code. It's because I still haven't got to the point where the actual if statement that determines if it's been 2 hours or not. And because I want to skip over the whole section that's doing the 2 hour check. So anytime you're doing trial and error, you want to just verify that your assumptions are correct. So I'm going to delete all the extra breakpoints I don't need. So I'm just going to delete all of them and then re-add the breakpoint here. And then with trial and error, you want to verify stuff. So I'm going to open the 1 minute map and load it. Make sure no breakpoints are hit. And it's not, because the game's totally playable. It hasn't frozen. If I was at a breakpoint, it would freeze. Now I'm going to reload the map that doesn't work and make sure I hit my breakpoint. Okay, I do. So I verified this. It looks like I'm at the very top of the program here, because if I keep scrolling up, there's no code. Well, this isn't really the top of the program. This is just the top of a function. So, or like a subroutine is another name for a function. So what I want to do is find out who calls the subroutine. So if I right click here and I say list cross references to, it'll show me all the other pieces of code that call here. So I need to find out which one of these is the one that executed. So I'm going to click on each one, add a breakpoint, and to add a breakpoint it's just the F2 key, so I'm going to start using that just to be a little faster. So I hit escape to go back to the previous screen I was on. I'm going to search again, grab the second one, add a breakpoint. Sorry, I'm going to go fast just because there's too many. I don't want it to take forever. So escape to go back, cross references. It's nice that it highlights the one I was on last, so I don't have to remember or count where I was at. So the reason I'm putting a breakpoint on all of these is it's possible that only one of these is the one I need to change. And so I want to find out which one it is. Now, when I try to add a breakpoint to this one, it gives me a weird pop-up. And also this code looks a little different than the others. So I'm just going to ignore this. I'm wondering if this is just defining the address where the function starts and it's not actually code like executing the function. I'm going to continue and then open up the map again. Got to reload Demacia and then see which breakpoint it is that's getting hit. So I'm going to do the same thing I did before. I'm going to disable this breakpoint and then keep the game going. Oh, so I don't care about this breakpoint anymore because I'm looking for the higher breakpoint because this is still too deep in the code. So continue. So the reason I disabled that breakpoint is so that I could reload it again and see if any of the other breakpoints are executed. And it looks like not, because the game is not frozen at a breakpoint. So that's good. So I don't need this one that I disabled. I'll just delete it. And then the one I do want is this one here that it hit, that I disabled. I want to re-enable that, but then I want to delete all the other ones. So all these other ones are obviously not related because they were not hit. And my guess is that this subroutine that I'm breaking on, it's to like render like a pop-up on the screen. So maybe this bottom one is to render the pop-up that says the demo of 2 hours is up. These other ones are probably to show other pop-ups on the screen. So that's why they're not really related. But I didn't have to read the code to figure that out. I just did it with trial and error. So this one I'm going to re-enable. So now I got to decide if I'm high enough up yet or not. So basically I'm going to do the same thing as before, where I'm just going to add more breakpoints going up. And so I'm just going to trace the direction it goes. I'm not going to go as far this time, just because I don't want to waste time in case I'm going too far. But what I want to do is I want to load the 1 minute game, because none of these breakpoints should be hit if I'm still within code that's related to hitting the 2 hour time limit. Okay, so a breakpoint did get hit. So that means I went too far, which is actually awesome news, because I know this bottom breakpoint is related to 2 hours of time limit. And I know this top breakpoint is not related to 2 hours of time limit, because this top one hit even for the 1 minute game. So that means it's within these like 20 lines of code here. So I've narrowed it down really well. So what I can do is just continue. Okay, now it hit the second breakpoint. I'm just going to disable these ones that have been hit. So I don't really want any breakpoints to get hit here, because any breakpoint that gets hit is not related to the 2 hour time limit, because I loaded a map that's not past 2 hours. So I'm going to continue again. Okay, it doesn't seem like it hit a breakpoint, so I'm going to go back into the game, make sure it's running. Okay, that was a little weird. The game was running for a second and then it came back to IDA, which means it hit this breakpoint again. This line of code must be executing frequently. But again, I don't think that this is related to the 2-hour time limit. So I'm going to disable it because I'm on a map that is, it's only been playing for 1 minute. But something odd here is it jumped back to the same breakpoint a second time, and it didn't jump down to this breakpoint down here. So that actually is kind of intriguing because I mentioned that it must have been between this top breakpoint, this one that I have highlighted green. It must have been between that one and this bottom one, like that, those like 15 lines of code. So the fact that it didn't execute here, but it did execute here, tells me it actually is probably in between these 3 lines of code. So that means I probably have found it. Let's just verify that. So if I hit continue, okay, the game is fully playable now, not frozen, so breakpoints are not getting hit, and that's because I disabled this one. So this red breakpoint here is not getting hit. But let me quit out of this map and load my 2-hour map and see if I hit a breakpoint. Okay, so that's great news. We totally narrowed it down. So we know that somewhere between this co-miss line, the JBE line, and this XOR line is checking the 2-hour time limit. Most likely it's related to this J because that means jump. So that's saying jump if below or equals to this other location. And where it's got the 2 arrows, this other location is down here, the 7450. So we know that this window here that has the red line inside of it, this is bad because this is what's like quitting us out of the game and showing us that error message. Because this breakpoint does not hit if it's on the 1 minute timer. So we basically want to skip over this, which means we never want to follow this left path. We always want to follow this right path, this green arrow on the right. And so we can do that by changing this JBE command. But just for fun, I want to just kind of analyze what this code is doing first. So we know that jump is based on a compare that came beforehand. I'm not really familiar with this co-miss command, but jumps are always based on compares, so it must be some kind of compare, and you can kind of assume COM probably means compare. And the reason I'm not familiar, I learned assembly language when computers were very new, before Windows existed, like 20 years ago, and I've not really ever touched it since. And so I use a much more simpler version of assembly language. A lot of new instructions have been added as computers have gotten more complicated. But anyway, so it's probably comparing 2 values. Obviously it's comparing the 2-hour time limits. The number of seconds in 2 hours, number of seconds in an hour. So 3600, 7200. The way we could verify that, let's re-enable this breakpoint. Okay, so I'm gonna go to the 1 minute game. Let's see what this XMM variable is. So here you can see it's 16. Basically this brand new game, I've been playing it for 16 seconds. I'm going to assume that this is a variable that says the number of seconds in 2 hours. So it should be like 7,200. So it's comparing those two and it's saying if it's below or equal, jump down to here. Otherwise, continue on here. And we know that continuing on is bad. So we basically want it to always jump instead of if it's below or equal. So that's actually pretty easy. All we've got to do is highlight the JBE that we want to change. Click Edit, Patch Program, Assemble. It put in the existing line of code that we already had. So instead of jump or if below or equal, I'm just going to say JMP, which says always jump no matter what, and hit OK. So anyways, now it says JMP instead. So I'm going to disable all my breakpoints, go back here. I'm going to continue the code, and because it should always jump, then no matter which map I load, it should hopefully work. So obviously this one's working fine because this one's at 16 seconds. But if I load the Demacia game, which has been going for 2 hours, then hopefully it doesn't hit a breakpoint, and hopefully it lets me keep playing. And it looks like it does. I mean, the game's totally playable, even though I've been going longer than 2 hours. And that pop-up did not show up. So we fixed it, but let me just mention a few things before I end the video. So first of all, if I come in here to the research, if you notice here, if I mouse over this homeschooling or propaganda, they both say not available in demo. So I mentioned earlier, I guess just kind of the ethics of hacking. So, you know, this is just for educational purposes. I'm not trying to steal money from the developer. If you choose to follow this guide, you're going to notice very quickly that the game is still not playable. This is just, you know, for educational purposes and just for fun. You can keep playing the game, but once you get here, nothing is available anymore unless you pay for the demo, and it goes on for quite a while. So I would really have to pay in order to have more content. And in addition to that, if I were to come in here to the main menu and do a new game, you can also see that all of these other maps, they're also all locked. So it says not available in demo. I haven't cracked any of that other stuff, and the reason why is because my intention is not to try to steal from the game. So I think this game is fun. I'll probably pay the 20 bucks. I just started playing it yesterday, so I hadn't had time to decide yet, and I just wanted to do hacking just for fun because, you know, needed a coding fix. But so anyways, all the stuff is still locked, and I'm not planning to hack any of that because at that point I feel like it would be more like stealing instead of just a fun little coding example. But then in addition, I really can't expand my town much bigger than this. I mean, I could just keep gaining more gold and keep building more buildings, but you can see here I don't have access to the merchants or jewelers yet, and there's like new types of houses that they need to live in, and there's just stuff I really can't play. One last thing, so because we patched this, it actually changed the memory of the program while it was running when I did this edit patch program. So if I like go to debugger and like detach and then close down IDA, the game will keep running and I should still be able to keep playing with that 2-hour limit. But if I close down the program and reopen it, then this command, if I'm not running IDA, this command will no longer be patched. So it'll go back to the original command it was on. And so it's also not like a permanent hack. Now, I could make it permanent if I wanted to, but there's not really a reason to do that. And also, I don't want anyone else to like redistribute a hacked version of the game because I don't want to contribute to piracy. So that's the basic tutorial of how to accomplish this. Hopefully you found it useful. Let me know in the comments below if you have any questions, and I think that's it. Thanks for watching.